In this video, we will solve a radical equation. Here we only have one radical in the problem, so our first step is to isolate that radical sign. We want it to be on one side by itself. To do so, we'll do the opposite of subtracting 5, so we will add 5 on both sides of our equation. Now on the left side of our equation, we have the square root of z plus 11 is equal to z plus 5. Now, in order to cancel out the radical sign, we need to do the opposite of square root. So we will square both sides of our equation. And whatever we do to the left side of our equation, we must also perform on the right as well. On the left side, squaring is the opposite of square root. So our result is just the radicand, everything under the radical sign. On the right, we have a binomial that's squared, so we must expand this binomial, z plus 5 times z plus 5. We will use the distributive property to multiply z plus 5 times z plus 5. We're going to take each term, the z, and multiply it by both of the terms in the back, and we will also take the 5 and multiply by both terms. Our result will be z squared plus 5z. That's from the first, z being multiplied, and then 5z again plus 25 from 5 times 5. On the right hand side, we're going to combine like terms. And now we see we have a quadratic equation, so we must set our problem equal to 0. Our opposite of adding z, we need to subtract z on both sides. Our opposite of adding 11, we need to subtract 11 on both sides. On the left side of our equation, we have 0. On the right side of our equation, z squared plus 9z is equal to, plus 14. Now, quadratic equations, we have 5 different ways we can solve. In this problem, we can factor. What two numbers can we multiply together to get a positive 14? But when we add those same numbers together, we get a positive 9. So this will be 7 and 2. And zero product property says we take each factor, set it equal to 0, and solve. So z equals -2 and z equals -7. Whenever we have any kind of equation, we need to always go back and check our solution to make sure that it works for our original equation. So if we're checking the value of -7 and plugging this into our original equation here, -7 plus 11 is 4. Square root of 4 gives us 2, and 2 minus 5 will give us a -3, not -7. So this value we call our z equals -7 is called an extraneous solution. Now, when we go back and check the value of -2, and we plug -2 into our original equation, we will have square root of 9 minus 5. Square root of 9 would be 3, and 3 minus 5 is -2. So since that value works, our final answer is -2.